Hi everyone, welcome back. This is the 50th video in our series on building a chess engine from scratch in the Java programming language. Today I have a special treat. I'm going to show you some gameplay from another game I'm currently working on that I plan to build a series on here in this channel. I just wanted to let you guys know that it's been really enjoyable for me to build this channel out. I don't want it to be only about chess, but I do want the focus to be on software design and game development, sort of a cross product of those things. A lot of you guys have asked me, when is the series going to be complete? My answer to that is that, I want us to get to a point where we have sort of a viable product, and we can always revisit and extend on it. It can be infinitely extendable. I can think of so many more videos that we could do, but I don't want you guys to feel like it's gonna, that you have to go all the way to that last video before it's quote unquote done. I want to just sort of seed thoughts on how to extend it. Having said that, let me do a quick video demonstration of a game I'm currently working on, and to sort of get you guys interested and pique your interest in the next project. So this is a game that I'm currently calling Things. I was inspired to build this after watching Westworld and seeing these, autonomous sort of android-like robots. And so here I have these little creatures in a world, if you will, and I am laying out food for them, and if they find the food, then they pick up the food and they take it back to their hive. I think it's very open-ended. I haven't really decided what direction I want to take this in, but I want to continue focusing on game development and design, and just aspects of play that I think are both good learning experiences and fun. So yeah. All right, so having said that, let me go back to our chess program, and our focus right now is on the Minimax algorithm. And I actually made a recording this afternoon, and I had problems with the audio, so the code is already built here, but in my IDE. So you're going to see me explaining the code in this video, and I hope that's okay with you guys. So the video will probably be a little bit shorter. But I promise to go back to the original sort of style and format of me typing the code out alongside with you guys after this video. Alright, so let's first look up, going back to our Minimax decision tree here. In your version of the code, you should have a comment block here where if depth is equal to 0, and I think your code says, or game over, right? What this is really encapsulating is saying, look, continue to search in the game tree only if the game hasn't ended, right? If I type in a depth of 6 and we reach a checkmate situation before we get all the way down to depth of 0 in searching for a move, then we should stop searching and evaluate that board, right? We should cut that tree off, and that's really what we're doing here in is endgame scenario. And you can see this method. It's a really simple static method that just checks for on the current board. For the board, it says, is the current player in checkmate or stalemate, right? In those scenarios, we don't want to continue searching further down, recursing further down in our min-max tree. We just want to evaluate that board using our heuristic evaluation routine. Okay, so I've added that here, and the only other change that I made was that I want you guys to recall in our move strategy, in your version of it, you are taking depth as a method on this interface, and I would argue that was a poor choice on my part. I think it would be better to have the interface be more generic and only really take the board into account, right? Because the notion of search depth is very specific to a very particular type of move strategy, the min-max. So instead what I did was I refactored that parameter not to be on this method, but to actually go on the constructor for Minimax. And I made a member field called search that, and I stored that on there, and I just go ahead and continue to use it in execute. But notice that the interface for execute doesn't need to know about it. Okay, so that was the only other change that I made there. And lastly, I introduced in my test board class a method called test foolsmate. And this is going to be the first test case that we write for our AI. And foolsmate, if you guys aren't aware of it, you can look it up in Wikipedia. It's the shortest checkmate in chess. Okay, so basically one scenario where you can end up in foolsmate here is illustrated here in this diagram. White opens with f2 to f3, and then black opens e7, e5. White then proceeds with g2, g4, and now black can go d8, h4, checkmate, right? So this is called fool's mate, and basically I'm using this as a simple litmus test for our AI. I want to be able to set up the fool's mate so that black can use its Minimax search strategy to find this d8, h4 move amongst all of its possible legal moves. Okay, so here you can see that that's exactly what I've done here, right? I construct a board, a standard board, right, the initial opening position, and I say board current player make move. I use our move factory to open with the move f2 to f3, and then I just assert that that move was completed. And then I handle e7, e5 for black, make sure that that move is completed. g2, g4 for white, make sure it's completed. And finally, I instantiate our newly created move strategy of type Minimax, and I give it a depth of 4 moves to look ahead. And I execute that AI move, right, for on the board, right, on the board that we exited after T3, after we made the G2, G4 move, right? I execute that move on the board, and I know just by looking up the definition, the best move is D8, H4. So I want to assert that the AI move is equal to the best move. Okay? So that's all I'm doing here in this test fool's mate. And guys, I really want to emphasize the importance of unit tests. If you haven't imported some of my unit tests from the GitHub repository into your source code, then you can't really be confident that you have implemented a working engine, let alone an AI. Okay, so please do that. I'm always happy to help people, in their project as necessary. But please do get in the habit of writing test cases. So now that I have this test case, I'm going to run it. And notice Minimax is not instantaneous. It takes some time to think. And we actually come back and the test is passing. It's green. Okay? So that really is it for this video. And, so some of you guys have asked, what's next? And what I'd like to do is I'd like to move next into hooking up the AI to the GUI, so the user can specify player versus human, human versus computer, or computer versus computer. And if you look in my AI directory on the GitHub repository, you'll see I have many different types of AIs. I don't want to cover all of them because, well, that's going to take a long time and many videos. So I'd like for us to, I'm glad that we went through Minimax. And our focus next should really be on the PGN parsing, FEN file, FEN parsing and PGN file parsing, and game databases. Right, having a book of moves that we can choose from for our opening. With all of that, I think we have a minimally viable product that you can either extend by looking at my source code on GitHub, or by making your own personalized extensions. And then from there on out, I'll start making more individuated videos, not really long series, on programming in general. Anyway, it's been really fun for me, guys. Please do help the channel out by liking and subscribing and passing the word around about the channel. I do intend on growing the channel and sharing as much as I have with you guys. And I really appreciate the feedback that you guys have given me, and just the patience that you've had. So yeah, so we will see you next time. Thanks.